just kind of give you sort of components of effective teaching that come from reviewing very broad as possible research that really apply to all levels and all settings. And so I'll just kind of leave you with this message without going into detail. What I've been really talking about here is very much this explicit, authentic practice of expert-like thinking, the kind of tasks you have to have, the kind of feedback to make that effective. But there's some other things that are really important, learning to support that. There's motivation, which I'll talk about more in a minute, and there's connecting with the student's prior thinking. I mean, if you get into the mode of thinking about learning as really development of a brain, you need to know where that brain's starting from. You have to have the appropriate tasks, you have the appropriate things to motivate that brain to put in the effort. And so that recognizing and dealing with prior thinking is really critical here. And then there's some other stuff that comes from a completely different area, which is just knowing how the mind, the basic level processes and learns and remembers information. And this is stuff that's really well studied, but really grossly neglected in a lot of educational practices. On the limitations on the brain and short-term stuff and achieving long-term retention. And although I'm not going to go into this stuff here, I will say that I think I gave to Bob, and you probably should have the materials you have, a packet or some files on a course transformation guide for, if you want to take a course and transform it to be completely different and better, putting in place all the research on learning. In there's more references, more discussion about some of these issues in as brief a way as I could make, and then also sets of specific strategies about, in a course, how you actually embody the different elements in this. And I also should make a point that up in 1 and 2 are really, so this gets in, this is where all your issues of diversity, where I mean that in the broadest general sense, the fact that one student's different from another. That's really where, previous experience, educational experiences, cultural values, etc., all come in up at that level, really. But that doesn't mean they're not important. Okay, so I'm going to focus and talk a little more about just one of these aspects and what research tells us about this, looking at motivation, and then some work that my group has done on looking attitudes and perceptions about physics and how it's learned, because those couple in strongly actually to motivation. I have to say, there's no particular reason to focus on this one, except that I was just annoyed recently again by Lily McDermott dismissing motivation as something that physics education research shouldn't be paying attention to. To me, that's like, if you're in the airline maintenance business, you say, oh, but anything attached to the left wing of the airplane doesn't belong in aircraft maintenance. It's just such a fundamental important point of learning that I'm going to tell you a little bit about what we know about it, how to improve it, why it's important. In fact, the cognitive psychology research in looking at this on expertise development, their strongest predictive elements that they can find of who's going to become more expert, I said at the beginning, these kind of measures of ability and talent, they can't find that these have any predictive, predictive value, but the strongest one is actually measures of motivation. That seems to be, and okay, you really shouldn't need research to tell you that. That if somebody doesn't want to learn something, they're not going to learn it, and somebody who really wants to learn something, they're going to learn it. Okay, so it's an absolutely fundamental element to learning. It's important that we pay attention to it, and if you pay attention to it with your students. So, it is complicated in any particular case because it depends on the individual, but I'll give you a few basic things that show over and over again in the research on how to enhance motivation to learn. One is making this, the learning the subject relevant, useful, interesting to the learner, and this almost always, not exclusively, but almost always, is greatly enhanced if you can find a context you can put this in so they can see why, from their perspective, why this is valuable and worth knowing. Now, I'll tell you a little story on this, that how one can easily go wrong. It's awfully easy for faculty to project their own expert knowledge and values into this process, and so I had one faculty member who was in computer science, so I won't insult, and talked about this, and so, he thought this was great. Came back a few weeks later, he was so excited because previously they had some complicated sorting programs, they're supposed to, students have to analyze. So he'd now given a real world context that's going to make it more interesting for the students. It was taking the computer science department and all the different faculty committees and figuring out all the different ways you could put faculty on all these committees. So, not too sure how excited the student. So just keep that in mind. It's the student's perspective, the learner's perspective on the motivation. But Bob knows that I picked, actually, the last time I gave this talk to your predecessors in this group, I actually took some ads from the physics teacher and the group, asking what was wrong with this picture, and nobody could tell me. And the fact was that all these ads are targeting what would seem interesting to a physics teacher, but would seem really stupid, frankly, and kind of irrelevant to a novice physics student about why physics was interesting. So, it's not just computer science people. It really requires one actively stepping back and understanding the student values to take this. Okay, the second thing that's very important for motivation is for the learner to have a sense that they can master the subject, how to go about mastering it, and so the more you can transmit that, the more motivated they'll be. And also, finally, and again, this is very general, that to the extent one can give any kind of sense of, even in a limited way, because you obviously can't turn the class over to students, but since they have a personal control or choice in the learning process, that makes people feel more motivated than if they feel it's completely different. So these are basically just human psychology. This isn't based on physics specific. Now there is some things that are quite physics specific, and that's and so I want to move to this to perceptions or attitudes about physics, and this is something my own group has worked on, and the University of Maryland group has also, Joe Reddish has studied. Because these couple into these things quite a bit. Joe didn't talk about this in his talk earlier, right?
We talked about it.
I'm seeing any head shaking somewhere.
A little bit.
Okay, well, I'll talk a little more about it. So, if you interview a bunch of people about their sort of, particularly students, about their beliefs about physics, you find you can classify those beliefs in certain areas on a scale from novice to expert, where we're talking about the content of physics. To an expert, it's these broadly, broad concepts that describe the world around you, and to what we classify as a novice, they think of physics as just a whole bunch of isolated little facts, and the way you learn physics is memorizing all those facts. And the source of physics knowledge, we all know these concepts describe nature and come from experiments, but to somebody who's novice beliefs they are just handed down by some arbitrary authority and don't have anything to do with the world outside the classroom. Now, I'm not endorsing these, but it's important to know that, reasonable people have these beliefs based on their experiences. And then physics problem solving. Okay, I'll skip about experts think about this. You all know that. Got strategies that work in completely new contexts and so on. And any of you know that there's a lot of students who think physics problem solving is just memorizing certain recipes, and if you're given those ingredients, you just mindlessly use those recipes. And so, my own group, we wanted to know more about this, how this is affected, how these perceptions are affected by different kinds of instructions, what they correlate with in terms of learning, and so on. And so we developed this CLAS survey where it's actually put a bunch of work. You have to go to a lot of work to get a valid survey, but I'll skip over that. Where takes students about 7 minutes to fill this out, where they just say their level of agreement and disagreement with these different statements. And then this is now used, just like the force concept inventory, in a pre-post basis of you measure the students' attitudes, perceptions about physics at the start of the course, you measure at the end of the course, and you see how instructions has affected those. And so the average student in a class is going to come in somewhere in the middle, you figure, and you want to see, okay, they haven't go through an introductory physics course, how much do they start to perceive physics more like an expert physicist? Well, that's what you'd like to see. The reality is that what we saw, and lots of other people in the Maryland group sees this, take these instruments and use in other courses, is that, at least for introductory physics courses, the average student is left at the end more novice-like in their beliefs about physics than they were before they started that course. If there's any, we also extended this work to develop similar things for biology and chemistry, and it turns out chemistry is probably a little worse than physics, biology is not the same. So we're not alone here, but this is a real problem, and it's a problem for several reasons. First, this isn't, my perspective, this isn't ineffective teaching. This is anti-effective teaching. Okay, so. But also, if you really think about what makes up a scientifically literate citizen and their views about science, and what somebody, who's espousing an anti-science view, you think about it, you realize they must have very novice, these kind of novice-like views about science. And so it's really, I think, it really is important for a lot of our educational goals. But beyond that, picking this up, we see that these measured perceptions, they correlate with most everything we think about as important, learning, conceptual mastery, blah, 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 that we have as educational goals. I want to stress, these say absolutely nothing about knowledge or ability about physics, okay? These are much more like religious beliefs that are just shaped by what they've encountered, who their neighbor was, what he had to say about physics, what their high school teacher did or didn't do, etc. Okay, and so this is completely independent of whether they could be a wonderful physicist or not. But given that, it's really a big concern and how important they are. And I'll just show you some work that Kathy Perkins has done looking at who ends up as a physics major 4 years later. She's been collecting data in Colorado now over enough years. She's got these longitudinal studies, so she can take somebody who's about to graduate as a physics major, go back and look at what did they answer on their CLAS survey the first week they arrived at the university, okay, 4 years earlier.